So now we're at one of the more challenging looking topics. I don't think it's actually that difficult. It's just kind of hard to kind of understand because it's so conceptual. It's trig. So trigonometry is one of those classes that's kind of just brushed in with algebra and pre-calculus, but it really should be its own class. In some states it is. So our goal for this unit is we're going to understand similarity ratios, proportions, and properties of acute triangles. So the idea here is, remember when we learned about how triangles are similar, and if they're similar, they can technically be different sizes. And this is due to a thing called proportionality. So, for example, if this was 3, this is 2, it would be similar to this if this was, let's say, 6 and this was 9. The ratios are still the same. It's still the same fraction, 2 over 3. 6 over 9 can become 2 over 3. So that ratio kind of creates the angles. Now, what trig is this idea of figuring out the angles based off of these fractions. And we're going to learn a little trick that every math teacher I've seen knows this trick. It's called SOHCAHTOA. And in order to understand this, you have to understand that if we're talking about an angle, every angle has, when we're talking about triangles at least, every angle has a different relationship with all three angles on the triangle. So, for example, the most obvious is opposite. The opposite side. And then it has these two sides here. Well, these are kind of harder to name, but usually when we're talking about triangles and in trig, we're talking about a right triangle. So this is perpendicular, meaning that this has to be the hypotenuse. So we've studied this before, the hypotenuse. You've probably seen it in other classes. It's the longest side of the triangle. So what about this other side next to it? Well, we're literally going to call it the side next to it. We're going to call it the adjacent side. Adjacent is another word for next to. So technically the hypotenuse is also an adjacent side, but it's the hypotenuse first and foremost. So we're always going to call this the hypotenuse, which leaves this other side kind of left without a name. So we call it the adjacent side. Now, the reason why these are so important, look at the letters O, A, H. In here, we're going to talk about 3 trig functions. And those trig functions are sine, cosine, and tangent. And we're going to get into that in this unit. I'm just going over it really quickly here. That way we can go through the slides a little faster. And sine is basically your opposite over your hypotenuse. Cosine is essentially your adjacent. Let me do it this way. Your adjacent side over your hypotenuse. And tangent is this idea of opposite over adjacent. So what happens here, and let me just let the lesson, but keep this in mind. Keep the SOHCAHTOA in mind. Sine, cosine, and tangent. We're going to learn about it in this lesson. All right. So for the introduction, so we're going to learn about how we can figure out angles based off the ratios. Basically our introduction here. So let's say we want to figure out how tall this is, but we know the rafter and the tie bar. So these are just things in construction. I honestly don't know what they were until I saw this slide. So we're going to use CD, the ratio of CD and AC. So CD, we're going to be talking about the king post. So we do know how big the king post is. All right. So CD is our king post. So I'm going to start highlighting that. That way we know what we're talking about. And then we're going to be talking about our AC. And our AC is our tie bar. So we're going to have to figure out our rafter here. So they're just demonstrating it using this picture. So let's go into the next one. And this is a short module. I was surprised how short this was. All right. So let's go into, sure. Oh, computer's loading slow. There we go. So now we're going to design a truss. So what is the measurement of the angle BAC? So let's go into our picture, trig ratios. What is the angle of BAC? BAC. And they're using similar triangles by going like, hey, this is similar to that triangle. So we needed to go B, where's their B? BAC. Oh, well, they tell us. That was easy. This was 36.87. So this is just going to be 36.87. And if we want to get fancy, we could have done it in the equation editor. I'm literally just going to put the equation editor, just to put the little degree sign. It's a little off because the texts aren't the same. How do triangles ABC are related? How do we know? Explain. So this we're going to say that the two triangles are similar. We know they, and I'll explain this as they are similar by side angle side. The angle is similar due to the reflexive property. Spelling it right, I was just saying it weird. Reflective property. And the other sides are proportional. So let me get into this. So if we go back into our GeoGebra, this right here is the same angle. So BAC is the same angle as DAE. So that's why I'm saying the reflexive property. The same angle. It is the same angle. And then where they're proportional, because if we look at the sides, look at AD and look at AB, you can double this. You can double this and you get that. You can double this and you get that. So that's why this is proportional by side and side. I didn't realize it. They also give us a third side. So technically you can even say it's proportional by side, side, side. All the sides are proportional. If you double all the sides of this triangle, you would get all the sides of the other triangle. The big triangle is twice as big as the smaller triangle. I'm just adding that just to put flavors. Make sure you're using your own words when you're completing your tutorials. Alright, and now we want to put in all of this. So I think they're going to prove it by side, side, side similarity. So AB. Alright, AB is 20. And we said AD is half that length. And we saw that it was 10. BC, they're being really nice. I'm surprised they're not making us measure. I think they're focusing more on trig. BC is 12. This next one is 6. AC is, where's AC? AC is 16. And the last one is 8. All right. So, oh, I'm almost forgetting to submit these. I'm so used to being in teacher mode. All right, so they confirmed it. So now they want us to divide. Well, if we do so BC over A. So they want us to do the opposite side over the hypotenuse. So BC over that. So we get 12 over 20. So using my little stylus here, give me a second. We have 12 over 20, which this will reduce down to 6 over 10, or I could have divided by 4, and in this case divided by 2, and we get 3 over 5. So we get 3/5 here. So what I'm going to do here is I'm going to use the equation editor to make it a fraction. And I'm going to say it's 3, use the down arrow to put the 5. Now we want to do the ratio of DE. Well, I have a feeling it's going to be the same thing. So DE is, where's DE? 6 over 10. Well, guess what? That is also 3/5. So what I'm going to do is I'm just going to borrow my little answer here because I know it's the same thing. Uh, you notice how I can't copy it? Well, you can just Control C here and then just do a Control V. All right, and now we're going to do AC and AB. So if we're doing AC and AB, we're going to do 16 over 20. 16 over 20. So let me grab my stylus here. 16 over 20. I get 4 over 5. I'm just dividing by 4 straight off the back this time. So I get 4 over 5. So again, I'm going to go to my equation editor, make it a fraction. Do 4, use the down arrow, put in the 5. Okay. And of course, we already know it's going to be proportional, but we can take a look at it anyways. We're going to be looking at 8 over 10, and again, that reduces to 4 over 5. So I'm just going to borrow my answer that I already have here. Control C, Control V. Next, I'm going to do BC over AC. So this is the opposite over the adjacent. So the opposite is 12, the adjacent is 16, and that's just going to be 3 over 4. 12 over 16. This is going to be 3 over 4. One thing that's cool is apparently all of these reduced by 4, because look, we have this over here to 3 from the last time we used the opposite, and then we have this 4 from the last time we used the adjacent. So this is just an interesting little thing I noticed, that they're all reducible by 3 or 4. You can divide all of them by 4. So I'm going to do 3 down 4. Put an OK there. All right, go here. Control C. I think I did. Okay. I accidentally did Control V, but luckily since I was highlighted, it didn't. Oh, did it do? Oh, it did. Since I had it highlighted and I accidentally did Control V, it pasted where I had it copied. So let me fix this again to be 3 over 4. So be careful when you're doing that because that V is right next to that C. All right, so let me OK this. Now I'm going to Control C. Use my wrong finger to do Control V. There we go. Perfect. So I'm going to submit that. They divided it out and put the decimal. It's the same thing. They wanted the decimal just in case you had trouble reducing. So, like I said, they're very nice on this activity. Despite the sizes of the two triangles, what do you notice about the ratios? The ratios are the same, and we noticed this before. It feels like each module is kind of taught differently. So, the ratios of the two triangles are the same. So the ratio of the two triangles are the same. All right, so let's move on here. Now change moving D. Okay, so we're going to move D here. So they want us to move this. I'm going to try to move it at a nice spot. So let me try to move it. You know what? I'm going to move it smaller. I'm going to move it to the point where all of the ratios are a lot easier to calculate. So I'm trying to get this to be 3 exactly, and I can't get it. Come on. It looks like it's on the odd numbers. Ah, wait. If I can get it to be 2, that means I can get it to be 3. I just gotta have a steady hand here. How did that even happen? I skipped it. I don't even understand why I can skip it. Oh, oh my gosh. There. Perfect. So it probably wasn't worth it, but I did make it. Oh, were we supposed to move it to F? Please tell me they didn't tell me to move it to F. How do you calculate the ratios? Okay. I made the triangle smaller, and yet the ratios were still the same. So, I mean, you could have done this without doing it, but I moved it this way because think of it this way: opposite over hypotenuse, 3/5; adjacent over hypotenuse, 4/5, obviously, and then finally opposite over adjacent, 3/4. Same thing. So that's where we're getting these from. All right, so the next one we're going to do is we're going to get into doing this. So they want us to move it several times. And honestly, I feel this is old hash. No matter where you move it, you're always going to have the same ratios. Oh, I see. They want us to actually move the angle. So that's going to actually change things. So, oh, sorry. They want us to change the angle. That will change things up a lot. Oh, wow. And you guys can actually use this to help you find the ratios a lot faster, which is going to be helpful for this one. So for this one, this is where they stop being nice. They're like, we're going to start changing things. All right, so I'm going to start making these angles. I'm going to try using the nicest angles I can. You'll learn about some of the angles I'm going to try to use. I'm trying to use, but I guess I can't. Darn. Oh well. So we're going to do 30.99. So 30.99. It wants us to do opposite over hypotenuse. So if we're doing opposite over hypotenuse, that's 0.51. 0.51. And it wants us to do. So I definitely recommend clicking this button, guys. It's going to be so much easier. Adjacent over hypotenuse. Adjacent over hypotenuse. That's 0.6. And they labeled it in a nice order so you can just do it a lot faster. Last one is going to be opposite over adjacent, and that's 0.6. So 0.6. All right. And we're going to do the same thing here. And I don't know why they're making us do this. Like, I get that it proves these are congruent, but we can just say they're congruent. They just want us to fill out this chart. All right, so let's do the next one. I'm going to move this a little lower. Then 27 point. And I'm just trying to zip through this for you guys. I didn't want this video that long since it didn't have that many slides. 0.47. 0.88. And the last one is 0.53. It actually might be faster for you guys to do this on your own than copying mine. So I do highly recommend doing your own angles just because I'm looking at this and I'm like, doing it is actually not that bad. All right. You guys don't have to wait for me to say anything either. 23.22, so I'm going to do 23.22 or 21. I always do that. I always say the wrong number. All right, we're going to do that. And then 0.39, oops, 0.39, 0.92, 0.43. I'm going to just copy everything I wrote in the top one. Feel free to use your arrows to kind of move around. So the arrows on your keyboard, they're really your friends when it comes to just typing. It just makes it so much easier to do that rather than using the mouse. The mouse will slow you down. I know it's more intuitive, like you want to do the mouse. Move to approximately. I was supposed to use these angles. Oh well. I've gotten pretty close to them. I'm a little off. Uh, so I didn't do the 60, 75. So follow the instructions instead of mine. I'm already mainly done. So let me try to do at least 75. So let me get to angle 75. Here's the tricky part. You want to make sure you're going up and down straight. Because if you go back in, that's going to mess you up. Let me make this smaller. 75. I think that's as close to 75 as I'm going to get. I probably should have zoomed out for this. I will in a second. That's close enough. Close enough. And I'm gonna move over. I didn't move over my things. This. Hmm, I was hoping I could make this a little better because all of these things are like overlapping, and I don't like that. Like I said, find your own preference. Do your own angles. As you saw, I did this wrong already. So I'm going to say 49.89 or 74.89. 74.89. First one is going to be 0.97. Next one is going to be 0.23 or 26. I don't know why I said 23. And the last one is 3.7. So notice after we got bigger than 45 degrees, it got a little bigger. So 45 degrees should be even. I should have honestly done it the way they did it. Those are special angles. And if we look here, they're basically the same thing. So if we do, what was it? If we do 45 degrees, it's supposed to be zero point 0.7. I think it's technically supposed to be 0.72. I'll do 0.71 because GeoGebra is basically doing 0.71 here. 0.71, and the last one should be 1. What's happening because they're even on both sides, it's supposed to be even. So after we get to 45 degrees, we go from getting a fraction for our tangent to getting a whole number. So let me do these. I really wish we would be able to copy and paste these, but I have a feeling if I did this, it's not going to like it. Yeah, it creates the table inside the table situation. I'm gonna go here, 0.97. 7. I'm gonna do 45.71, 0.71. Ah, don't know what happened there. What's going on? I'm not selecting more than one thing. I'm just trying to do. Wow, they did not make this an actual table, so this isn't letting me enter it in there. Oh, well, let me submit it. And you can see here, if you got really close to it, as soon as we got bigger than 45 degrees, we started getting a whole number. So it goes, your tangent gets bigger the bigger your angle gets. What do you observe from changing the measurements? Okay. Tangent becomes, I'm so sorry guys, it becomes bigger as the angle becomes bigger. Oh, and I don't think you guys have learned the name for it. Tangent is opposite over adjacent. Well, you guys know now. The next one we're gonna learn about is sine. Sine sine also becomes bigger. So not just tangent, tangent and sine become bigger. Our cosine, if we look at our cosine gets here it is, cosine. Our cosine actually gets smaller as the angle becomes bigger, but cosine becomes smaller. I recommend using these names. I know GeoGebra, Edmentum hasn't taught you them yet, but it's a lot faster than saying your opposite over hypotenuse, this and that. So that's why I taught you that earlier. And they're saying this. So this is another reason why it's good to do your own answers than to copy a sample answer. It's just too much work. It doesn't explain it. Blah, blah, blah. What do the ratios and the side lengths of a right triangle depend on? In particular, do they depend on the side lengths? What about the angle measurements in the right triangle? So we're not going to talk about the side lengths because guess what? When we did this, the side lengths didn't affect it. They were the same the whole way through. So the ratios do not. Oh, I'm going to say it in fancy words, but basically it doesn't depend on the side length. I'm going to say are not dependent on the side lengths. They are dependent on the angle of the triangle. So basically what I'm saying here is the side lengths, the sides don't matter. They don't affect the fraction. So the side lengths aren't affecting the fraction. They only the angle does affect the fraction. So I'm gonna put I need to read directions. I need to read directions. I picked random angles at first. So I kind of just picked random angles at first, and that's not good. Did I forget to submit something? I did. I forgot to submit this. I forgot to submit the first ones. I need to get better at submitting stuff. Erase all that stuff. Go to the next one. We're on slide 7 out of 10, guys. So now that's when they teach us about sine, cosine, and tangent, and how this. But what's happening here is this function takes an angle and spits out that fraction. Later on, we're going to learn about the opposite when we can take the fraction and spit out an angle. But for right now, these weird little buttons right here, that's going to spit out something. So let's say I did 1. Let's say I took the tangent. Oh, I'm sorry. Let me clear this out. Let's say I did the tangent of 45. So I'm going to do 45 degrees. I believe this, yeah, it's already set to degrees. Oops, I did not mean to do that. I'm sorry. So it's already set to degrees. So I'm going to say 45 degrees. And I'm going to say the tangent. We get that one that I was talking about. So we're going to be using this part of the calculator a bit. All right, let's go to the next slide. So what we're doing here is we're going to take a look at this triangle and solve it. And we're talking about angle A for some of them and angle B for the other one. So be really careful. So we're talking about 3 over 4. 3 over 4, well, that looks like my opposite and adjacent for A. So opposite and adjacent. So let me write this down so we have it as reference. So Toa. So opposite over adjacent for A. So opposite over adjacent is tangent. So I'm looking for tangent of A. Oh, sweet. It's right here. The next one I'm looking for is 4 over 3. Well, that's adjacent over opposite, but that's a little weird. We haven't dealt with adjacent over opposite yet. So maybe let me look at B. Well, when I look at B, 4 over 3 would be my opposite over adjacent. So now I'm talking about angle B, not angle A. So what I'm going to do here is I'm going to look at this and I'm like, oh, cool, it's a tangent of this. And this is actually interesting. On a triangle, if you flip over your fraction, if you flip over your fraction, it's basically going to be the opposite acute angle. So acute, remember, acute means small angle. So if we're dealing with a right triangle, both of these are acute because there's no way they can be bigger than 90 because a triangle only has 180 degrees. All right, so the next thing we're going to do is we're going to do 3 over 5. So if I look 3 over 5, 3 over 5, that looks like my opposite over hypotenuse. So that would be my sine of A. I don't have a sine of A, so I have to do B. That's going to be my adjacent over hypotenuse. So that's going to be my cosine of B, cosine of B. So I'm going to put my cosine of B there. Next, I'm going to do 4 over 5. Well, that's my adjacent over hypotenuse, but it's my adjacent over hypotenuse of A. So that's how we use SOHCAHTOA. It's cosine. Cosine, ignore the A for right now. Cosine of an angle is the adjacent over hypotenuse. And so on and so forth for the S, for the sine, and for the tangent. All right, guys. And that was it. So now we're going to, so that's basically our SOHCAHTOA. So I think they actually talk about SOHCAHTOA a little later, but for right now, this is what you have to have memorized and what I'm going to put on the Kahoot on Tuesday. All right, so see you guys later.